In this video, I'm going to talk about the difference between connection ratio and diversity, and how to use both to properly select an optimized system. Before we start, let's define a couple of terms. Let's start off with connection ratio. If you look at both the outdoor and the indoor unit, they both have nominal capacities. To calculate connection ratio, you'll have to add up the sum of all the fan coil units, add up all their nominal capacities, and divide it by the outdoor unit's nominal capacity. You take that number and you multiply it by 100 and you get a percentage, and we use this number as connection ratio. If you take 6 fan coils who all have a 2.5 ton nominal capacity, so a 30 nominal capacity, and you divide it by an outdoor unit which has a nominal capacity of say 192, you do the math and you get a connection ratio of 125 or 125%. So this connection ratio is used by different VRF and VRV manufacturers to define system limits. It is not the same as building diversity. One of the mistakes that I see often is that people will use this connection ratio and automatically think that this outdoor unit can now magically do 100%, over 100% of its nominal rated capacity, which is not true. So let's now define diversity or building diversity. Diversity is the concept that it is unlikely that a building's zone peak load will happen at the same time. So the basic idea behind diversity is that if you take a building and all its different rooms and zones, the idea of diversity means that all of those rooms won't be used or won't be at their peak load at the same time. I mean, if you think about it, it's kind of unrealistic, except for maybe in a data center. But if you take your typical office building with offices and conference rooms and different spaces, those won't all be used at the same time. So a building's diversity means that it's the idea that a building's maximum or peak load won't happen at the same time. There are 3 different ways to select a VRF system. There's sizing it to 100% connection ratio, there's designing it to peak load, and there's designing it to block load. I'm going to take a look at each one of those methods. The most straightforward way of designing a system is through 100% connection ratio. So this means that you'll take a look at the peak loads in each zone, and you'll pick the nominal capacity of the fan coil that will cover that zone's peak load, and then you'll take the sum of those loads or those nominal capacities and just simply match it to the outdoor unit. This is the easiest way to guarantee that an outdoor unit will meet the building's load. So if we design a system based off of peak load, the outdoor unit is sized to achieve the combined peak demand of every indoor unit on the system. This method often reduces the size of the outdoor unit compared to sizing it to 100% connection ratio. And in this case, the connection ratio will almost always exceed 100%. Now, if we take a look at block load, which is how we prefer to size every VRF system, the outdoor unit is sized to achieve the calculated peak load demand of all the fan coils at a given time of day on a specific day of the year, usually the hottest day of the year. The way the occupants use the building and its spaces varies depending on the space function and the time of the day. So this method takes into account a building's diversity. So let's take a look at the whole system design. The way I like to do this is first take a look at the indoor units and select the indoor units. Depending on your location, whether you design to cooling or to heating, I'm based in Southern California, so this is going to assume we're going to be selecting the system based off of cooling. You'll select the fan coils based off of their peak cooling load. And usually your engineer will give you this information. They'll provide you total and sensible cooling loads that they're trying to meet in each zone. And when selecting the outdoor units, we'll need to know the ambient conditions of the location of the project. Engineers or design build contractors will give you this information, or you can just look this up in ASHRAE data tables. And with VRF, as many of you know, there are certain refrigerant piping limitations that come with sizing VRF. So knowing the location of the fan coils and the other indoor components will help us design a proper system. So let's take a look at an example floor plan, and I'll go through sizing the fan coils in the system using the 3 different ways. So first, let's take a look at sizing on 100% connection ratio. So we have these 8 rooms, and for this example, I made it pretty simple. If you look at the total loads, you'll notice that they're all pretty much the same or in line with one another, just to make it easier. So if we're sizing these based off of 100% connection ratio, you'll see that the nominal fan coil size for all of these zones is 30,000 BTU, or 2.5 tons. Depending on the manufacturer and their selection software, there's usually a checkbox that will force or auto select an outdoor unit based on the connection ratio that you set in the software. So if you're gonna select a system based off of 100% connection ratio, you'll just go ahead and click on the checkbox, scroll down, select 100%, and it will automatically select an outdoor unit that will meet 100% connection ratio of the fan coils connected. Now let's go over sizing based off of peak loads. If you take a look at the floor plan and the peak loads for each room, if you add all of those up, you'll get a value of 197,170 BTU. Now you'll notice when you select this in your software, it'll still be the 2.5 ton fan coil that we selected before. The 2.5 ton fan coil will more than adequately cover how much cooling you need in that space. But since we calculated the peak load to be 197,170 BTU, we can actually select an outdoor unit that will closely match or cover that combined peak load. So now that we know that our combined peak load is 197,000 BTU, we can now select the outdoor unit. And since we know the peak load, we can select an outdoor unit that will adequately cover the peak load of the fan coils. So in this case, it'll be a size 216 outdoor unit. So now let's take a look at sizing to block load. So when we talk about peak loads in relation to the fan coils, this takes into account a lot of different things. Occupancy, people in the room, equipment in the room, anything that's generating heat, lights, computers, and also obviously the time of day and when during the year that these peak loads happen. So typically engineers will size based on the hottest day of the year. The engineer can also provide you the time of day approximately that these peak loads happen in the space. So this is what's known as block load. So you can take all of this information that the engineer gives you, the peak loads of the room, the occupancy, and when they think that the peak load will happen in that room on the hottest day of the year. And you can take all of that information and look based on the time of day even, the absolute maximum peak load that the system or that the building will see at any given time. And this is what's known as block load. And if you take a look at this chart that I put together, it takes a look at the different zones and different times of day, and at the different times of day, which rooms are at their peak load. So if you look at the chart, you'll see that during the course of the day, different rooms get occupied at different times, but you'll see at 2 p.m. on the hottest day of the year, July 31st or whatever, you'll see that the block load of the system occurs at 2 p.m. And you'll see at 2 p.m. that the block load is 186,000 BTU. So now using that information, we can now select an outdoor unit that will cover the peak block cooling demand on the hottest day of the year. So in this case, we can go down to a size 192 outdoor unit and still be able to cover the cooling load of the space on the hottest day of the year. So if you look at this chart, it shows you how using different selection methods can vary greatly in the selection of your outdoor unit. So if you look at the 100% connection ratio method, it says that it shows that we should pick a 20-ton outdoor unit. If we look at the peak load method, it says that we should probably select a size 216. And if you look at a block load method, it shows that we should select a size 192 outdoor unit. So you can see that depending on the method that you select a system, you can go anywhere from a size 20-ton outdoor unit to all the way down to a size 192. So I just wanted to show that depending on the selection method that you pick, it can vary greatly on the size of your system. So why do we want to select based off of block load? One, it produces a more efficient system design. I mean, obviously you can see that it lowered the size of our outdoor unit from a size 240 to a size 192. So that's a savings in probably electrical, savings in weight, and in some cases you can actually go from a dual module down to a single module, or from a triple module down to a dual module. It's also more efficient because you're sizing exactly for the peak block load of the system. If you select a 20-ton system, the building might not ever see a 20-ton load, so all that extra capacity of the outdoor unit is simply not used, and it's simply going to waste. I hope you enjoyed this video talking about the differences between connection ratio and building diversity and how to properly select a VRF system. If you want to see more content like this, please leave me a comment down below or hit that like button, and I'll see you guys in the next video. Thanks.